let's review finding all of the rational and irrational and complex zeros of a polynomial. So here's an example from your homework. You have a function, a very long function, has at least 2 integer roots, meaning it's not going to be a square root, it's not going to be an I, it is not going to be a fraction, it is going to be some type of integer, -1, -4, 7, 3. It's going to be some number. And we're going to find those roots, and then we're going to find all of the other answers. So here's how you would solve this. You first have to use synthetic division. Now, I know that the number 1 is going to work. Why? Because 1 plus 1 minus 27 minus 25 plus 50 actually gives me 0. These coefficients, if you add them together, they're going to give you 0. Therefore, I know the number 1 works. That's just a trick from class the other day. Okay, I'm going to bring down my 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. They add to give you -25. Multiply, give you -25. This gives you a -50. Remember, you're adding. 1 times -50 is -50, and you add and get 0. Okay, so we know that x equals 1 is a solution. Here's the problem. This is not a quadratic. This is an x cubed. How do I know? Because it started with an x to the 4th, which means this is an x cubed. We don't know how to factor that yet. So what you're going to do is take this answer and you're going to do the synthetic division again. And now you're just going to have to guess based off of your last term. It is a 50 and the first was a 1, which means the factors are 1, 2, 5, 10, 25. We're not sure what those numbers are, but those are the only possibilities we can put in the shelf. And so I'm going to try, okay, I'm going to try -2. -25. When I multiply out, I get a +50. And that did work. So I know that x equals -2 is also a 0. Now we are down to an x squared, which is a quadratic. Now we can find our other answers. So I'm going to write this as a quadratic. And now I'm going to solve. Because x only has one term, I can go ahead and just add 25 to both sides. And I'll get x squared equals 25. And now this is a square root of both sides. And I will get x equals a plus or minus, because you did the square root, of 5, which means I know that my other answers are 5 and -5. That was an x to the 4th. I found 4 answers, so I have found all of my answers. Next, they tell us that it has at least 2 rational zeros. That means it could be like -1, -3, 5, 7, or it could be a fraction, which means it could be 1/2, it could be 3/4. So we're going to have to check it by synthetic division. So I know this is a 4. I also know that 1 works. Why? Because 4 minus 24 plus 39 minus 4 minus 15 gives me 0 if you add them all together. So I know that a 1 works. So I'm going to bring down the 4 and multiply and add, multiply and add, multiply, add, multiply, and add. Okay, so I know x equals 1 works. Now, that was an x to the 4th. This is x cubed. I do not know how to solve this. So, synthetic division again. Okay, at this point, you need to look at all possible, which is plus or minus the factors of 15 divided by plus or minus the factors of 4, which means you can have 1, 3, 5, 15 all over 1, 2, 4, which means you could have an integer or you could have a fraction at this point. We are not sure. We know that 2 does not work. We've already tried 1. We know that 1 doesn't work. We could go ahead and try a 3. Oh, and 3 works. So we know that we are now down to an x squared. So you can either keep going with synthetic division or you can go ahead and rewrite it as a quadratic and either do the illegal move, which does work, or you can do the quadratic formula. If we do these, I'll show both. Illegal move, 4 times negative 5 is negative 20, and you got to add or subtract to get negative 8, and I believe you get negative 10 and a 2, because they multiply give you negative 20, but they add to give you negative 8. So I know that it's going to be x minus 10 and x plus 2, but we're not done because it's the illegal move. We have to take that first number where we multiplied at the beginning. We now have to divide and reduce. This will give me 5 halves. This will give me 1 half. And now we could swing it in front, but we're solving for 0. So I would go ahead and just set them both equal to 0. And so I know that x equals 5 halves, and I know that x equals a negative 1 half. So x equals 5 halves, x equals negative 1 half, and from this 3, we knew that that worked. And that was 4 zeros, and that was an x to the 4, so it did work. If you did not want to use a legal move and want to use synthetic division, quadratic formula, over here I would get negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll get 8 plus or minus the square root of 64 plus 80, which gives me 144 all over 8. Well, the square root of 144 is 12, and so I will get 8 plus 12 over 8, and I will get 8 minus 12 over 8, which is exactly what I got over here. 8 plus 12 is 20 over 8. 8 minus 12 is a negative 4 over 8. And both of these reduce. 20 over 8 reduces to 5 halves. Negative 4 over 8 reduces to negative 1 half. And so that's how you would get the answers of 5 halves and negative 1 half. Same thing here. You're going to have one rational root, and the other ones possibly could be complex. So first thing you're going to do is synthetic division. So I'll get a 12, negative 1, negative 7, and 2. We got to figure out what's on the shelf. So you're looking for possibilities. It is going to be plus or minus the factors of 2 divided by the factors of 12, which means on top you'll have a 1 or a 2. On bottom you could have a 1, 2, 3, 4, 6, 12. So to find out what's on the shelf, just start with, let's go ahead and start with nice numbers. Like it could be a 1 or a 2. So let's go ahead and try negative 2. I get 12, I get negative 24, I get negative 25, I get 50. Nope, it's getting too big, too fast. Okay, so we know that an integer does not work, which means it's going to be a fraction. All right, we've tried 1 and we've tried 2. Now let's try 1 half then. So I'm bringing down to 12. 1 half of 12 is 6. 6 and negative 1 is 5. Nope, I'm getting into fractions because that gives me 5 halves. Nope, that does not work. We could try a negative 1 half. Bring down the 12. I'll get negative 6, but I get negative 7 automatically the moment I get a negative. The moment I get an odd, a half of 7 is going to give me 7 halves. And now I'm getting into fractions. So that's not going to work. All right, we've tried 1 half. Now let's try 1/3. Bring down the 12. A third of 12, 3 goes into 12 4 times. Negative 1 and 4 gives me 3. Ooh, this still works. 1/3 times 3 is 1. Negative 7 plus 1 is negative 6. 1/3 times 6, well, 3 goes into 6, negative 6. Negative 2 times, and we actually found a 0. So we know that 1/3 works. Now we're down to a quadratic. The moment you get to an x squared, you can go ahead and rewrite it. And from here, you can either do synthetic division. I'm sorry, not synthetic. You can either do a quadratic formula or you can try to do a illegal move. At this point, I'm just going to go straight to quadratic. So A is 12, B is 3, C is negative 6. So I'll get negative B plus or minus the square root of B squared, which is 9, because 3 squared is 9, minus 4AC all over 2A. So I get negative 3 plus or minus the square root of 9 minus 4 times 12 times negative 6 is positive 297 all over 24. At this point, I need to check and see, is there a perfect square that goes into the square root? And it actually does. Square root of 9 times square root of 33. You may ask, how in the world did I know that 9 goes in there? So here's what I have to do. This is an odd number, so I know I'm not going to check an even perfect square. So like, I'm not going to check the square root of 4. I'm not going to check the square root of 16. I'm not going to check the square root of 36 because this is odd. So I decided to go ahead and check other perfect squares, which would be like 9, 25, which I know 25 doesn't work because it does end in a 5. Try 49. That's the ones you're going to try. And so I started with 9. So I divided this by 9 and I got 33. So I know that this is the square root of 9 times 33. So therefore, I'm going to rewrite this as negative 3 plus or minus. The square root of 9 is the number 3, and I'm left with the square root of 33 all over 24. Now, 3, 3, and 24, don't do the square root because that number is trapped. But these whole numbers all have a 3 in common, so I'm going to divide by 3. So negative 3 divided by 3 is 1. 3 divided by 3 is 1, leaving me the square root. And 24 divided by 3 is 8. And those are the other two answers. 1/3 was an answer, and then negative 1 plus the square root of 33 over 8 is an answer, and negative 1 minus the square root of 33 over 8 was an answer. Now, there is something you actually could have done to make this easier. You could have divided by, you could have factored out. Over here, you could have actually factored out a 3. And then, since this is all factors, you could divide both sides by 3, leaving you 4x squared plus x minus 2 equals 0. And then you could have done the quadratic formula, and you would have gotten the exact same thing. Last, we're going to try one more if you need any extra practice. Synthetic division, 5, negative 1, negative 6, 1, 1. If you add these together, 5 minus 1 minus 6 plus 1 plus 1, you do get 0. So I know that the number 1 works. Bring down the 5, multiply, I get 5. Add, I get 4. Multiply, I get 4. Add, I get negative 2. Multiply, I get negative 2. Add, I get negative 1. Multiply, negative 1, and 0. Okay, so I know that x equals 1 works. Now, we got to do it again. This is where you do need to possibly check possibilities. This is plus or minus a 1 over plus or minus a 5. So it could be 1 or it could be 1/5. We're not sure. Let's go ahead and try negative 1 first because it's a nice number. So let's actually try negative 1. 5, I multiply, I get negative 5. Add, I get negative 1. Multiply, I get a positive 1. Add, I get negative 1. Multiply, I get a positive 1. Thankfully, that worked. Okay. We are down to an x squared, which means I'm going to rewrite this as 5x squared minus x minus 1. Now you're going to have to use quadratic. This illegal move will not work. So a is 5, b is negative 1, c is negative 1. So I'll get negative b plus or minus the square root of b squared. Negative 1 squared is 1 minus 4 times a times c all over 2 times a. So I'll get 1 plus or minus the square root of 1 plus 20 is 21 all over 10. You cannot reduce that at all. There's not a perfect square that goes in there, which means my other answers are going to be 1 plus the square root of 21 over 10 and 1 minus the square root of 21 over 10. And there's your, oh, not 3 answers. Just kidding. Because we forgot that x equals negative 1 also worked. Don't forget the shelf numbers that do work. And I knew that that was true because I realized this is an x to the 4th, and I only had 3 x's listed, which means I knew I was missing one.